Hi, I'm Shine2C, and today we're going to cover the basics of volumetric rendering inside of V-Ray for Nuke. To do this, I'm going to use the ball in our previous tutorials and a light rect to generate some kind of a God ray effect coming from this direction. To generate a volumetric grid or volume render inside of V-Ray, you'll require something called a V-Ray environmental fog. This can be found in the V-Ray render tab, render, and environmental fog. So what I'm just going to do is go ahead and connect this to our tree, and the first thing we notice is that we're not getting a volumetric rendering at all. What we're actually getting is what looks like a plain surface and a cast shadow. What this is actually is our volume fog. It's just the height is really low and our scene scale is quite large. So this means that V-Ray is filling this invisible box full of volume, and we need to increase the height to fill our screen space. So what I'm going to do is increase this to 2500 and see what kind of results we get. Alright, so we've got black. Yay. Now that's not really a bug or anything. That's really because that the fog density is really thick. Now you see here you have the fog distance and the fog density. Now the fog distance and height do affect density as well. So if I just go ahead and grab these values and plug into fog distance, we'll start to see our ball and our light rig, and what it seems to be illuminating is a fog. So what we need to do is that we need to find a right balance here. So the fog distance means the wall of the fog is like the maximum, like you cannot see past this wall. This is what the fog distance is. Now the fog density is like how thick is this wall. Now if you keep increasing the fog distance, you'll get to see more of the environment. But if you bring a lot closer, which is like in that previously was a value of 10, it means at a certain point in space that you're no longer able to see the geometries and it's very, very foggy. So what I'm going to do is divide this by 2 to get we get back a thick render, and I'm going to bring my fog density into half. So we just basically go back to exactly where we were. Now what we notice is that I don't have a God ray effect at all. I just got like a glow effect. So why is this happening? The light rec by default is, well, a light rec is actually an aerial light, and by default is set to the value of 0. So it means the direction of the light is evenly spread along its solid angle of 180 degrees. To get that kind of a God ray effect we're looking for, we need to increase the light direction. So if I bring this into something like 7 or 8, yeah, so we have more of a God ray effect, except now we have a different issue that is incredibly noisy. That it's so noisy that we can't even see the God ray effect. So my general rule of thumb is when you're cleaning up volumetric rendering is that the question is where is the noise? If the noise is surrounded on the right, it means that its light subdivision needs to go up. If the noise is evenly distributed along the environment, like for here, for example, there's a lot of noise, this means the environmental fog subdivision needs to go up. So if we go ahead and double click on our environmental fog, we notice the subdivision is to 1, which is very low. So let's go ahead and increase this to 8. And we see that we're starting to clean up the noise. Now this is more of a desired effect that we're looking for. There we go. We got some nice little God ray effect, but this isn't enough. So what I'm just going to do is, I already know, like let's bring it up to 32, see what kind of results we get. Okay, so we've definitely reduced our noise. It's a lot cleaner now, but now we have this noise around the light. So what I'm going to do is pause this and just zoom in a bit and create this bounding box. And instead of V-Ray light rec, I'm just going to go ahead and increase this to something like 32. Because that seemed to be the magic number for our fog that it cleaned up fairly well. So when I do hit this at 32, I'm expecting these little spots over here to get cleaned up as well. Now we see, yeah, it's starting to halve the noise, but not as denoise as I would like it to be. So I don't really need to let this render finish, because I already know that this has to be somewhere along the line of 64. So it seems that our magic numbers were 32 and 64 for our cleaner render file volumetrics rendering. But now we have a bit of an issue that this kind of these optimized settings are giving us a really good clean render, but we want a really good workflow so we can move this render line quite quickly and get a good result, and then when we hit render, it obviously comes out nice and clean. So for workflow, I'm going to show you two methodologies to approaching this kind of work. One, we're going to show you a $GUI expression inside of Nuke. So what I'm going to do is add an expression to the subdiv tab and type in the word $GUI, and what this means, that is, when in GUI, or when you are viewing the the node, you'll only want 8 subdivision. And if I put a double color and say 64, this will render, when it comes to render time, it would render a 64 subdivision. So your renders are clean, but whilst you're working, you'll have a fast response, but it's a bit noisy. And now if I release this, we're able to get a faster response. So we can quickly set up and lay out a volumetric effect to get the desired effect we're looking for. And when it goes into the render farm, we'll get a cleaner render. So you're most likely wondering that, do I have to do this for every single node? Now, not necessarily. I'm going to show you some more advanced stuff. So if you want to go with a $GUI expression, that is one option. What I'm going to do is reverse the expressions I did, and I'm going to expose you something called a post-trans tab inside a V-Ray render node. So the post-transcript is Python scripts that are related to V-Ray. Now this is calling any functions or any global override that you want to do to V-Ray. So what I'm going to do is, I have an expression written here which is calling the DMC multiplier, and what this does is that inside of V-Ray internally, it multiplies all the subdivision of the materials to 0.1. So if I go ahead and copy this, right, and come back to my render element, and now look at our render, we'll get a very fast render time, right? But we're getting a lot of noise. But what it means is that we don't need to go into every single parameter and modify it to $GUI expression, which is later on is very hard to maintain. And if I want to make this even faster, I'll just go here and put like a .01, and I'll get the same noise that I will get if I had them set at 8. But then later on, I can just eliminate that Python script, and I will get a faster, and I'll get my clean render. And the best part about it is, because it's a global multiplier, I can even go higher. I don't need to go down, so I can go to the value 2, and it doubles the value of all of my subdivisions. So if I, for example, needed a super clean render and I had tons of lights, I don't have time to jump into every single light. I can just apply this Python script in the post transcript, and it will increase the subdivision globally for all of my lights. I'd like to thank you so much for watching this video. I hope this was informative to your work and any work you'll be doing in the future with V-Ray. And please come back for more. Have a good day. Bye.